Hey guys, what's up? So today we're going to be looking at frequency polygons, all right? And another way of representing a frequency distribution graphically is by drawing a graph called a frequency polygon. All right, guys? So the frequency polygon for ungroup data is obtained by plotting the observation or variable against the corresponding frequency and then drawing straight lines in order to join consecutive points. These observations are equivalent to the midpoints of the columns of the histogram. So the area under the frequency polygon is directly proportional to the total frequency of the distribution. So what does this mean, guys? It's easy to read this, but what does this really mean, right? But what we're gonna actually do is we're gonna look at an example, and I'm gonna give you an example right now of a frequency polygon right away. All right, guys. So I'm gonna clear the screen for a second, and if we zoom in on this little graph here, we can see that there's a frequency polygon here. Okay, and this is exactly how it would look, guys. And as we can see here, you basically plot the points, right? And when you plot these points, you have to draw a line through them, right? Starting from the midpoint of whichever year or whichever um, variable or time period you're using on the x-axis, right? So in this case, we're going to actually do this example, and it starts from the year 2000, then it goes to the year 2001, 2002, 2003, 2004, 2005, 2006, and so on, all the way till 2010, and 2011 has 0, and 2000 has 0. 2000 and 2011 are genuinely just used as placeholder points in these cases in order to draw the frequency polygon properly. All right, guys. So what we actually have to do is, if we look back at the notes here, it says the area under the frequency polygon is directly proportional to the total frequency of the distribution, right? This should actually be total frequency of the distribution. Now, what does that mean? So basically, that basically means that for this frequency polygon, we have to find the area of this shaded region, like the area of in here. And the only way to find the area of in here is to actually sit and find each individual area. So for this case right here, it's a triangle. We'll have to find that triangle. For this case, it's a triangle as well. And for all the other areas here, so I have A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, and A11. For all these other areas here, I have to find the area for these regions, right? So for this one, A1, we actually have to use the area of a triangle, which we know, right, it's the area of a triangle, which is really not hard to figure out. Same thing here for A11, it's the area of a triangle. And then for the others, we actually have to use the area of a trapezium, which is half of A plus B times H, okay? So to find the area under the frequency polygon, we actually need the area of each trapezium, right? So let's call this A0 in the case where you have trapeziums, and in the case where you have a triangle, it would be the same half base times height, right? Pretty easy to find out. So this is for the triangle, and A0 here is for the trapezium. All right, guys, so let me just give you an example here of the frequency polygon. The first thing we do is we get the point that's in the base here, and then we'll plot the midpoints of the histogram, right? So the midpoints, and then we connect the points, and after we connect these points, we have to find the areas, right? Pretty simple, guys. But don't worry, we're gonna do an example to explain what I mean. And this area is a triangle, so we'd find the area of A1. A2 is for a trapezium, right? This is the height, this is the base, and the other side is A, right? And you have to find A3, which is also a trapezium, A4, which is a trapezium, A5, A6, and then A7, which is also a triangle here. And once we find all these areas, then we should be able to, if we find all the areas and the areas come up to exactly the total frequency, then we know it's correct. All right, guys. Okay, so let's look at an example now. All right. All right, guys, great. So let's look at this example now. And the example says the table below shows the number of hit records Lil Wayne had during the years ending 2001, 2002, 2003, 04, 05, 06, 07, 08, 2009, and 2010, right? And you guys probably don't remember these times, but I do. And the first one says draw a frequency polygon to represent the info on a graph paper. All right. So I'm just going to look at the graph paper we did before, and this actually plots it. All right, guys, this is actually the graph paper here. This is the exact plot for it. Now, as you can see here, the year actually doesn't start at 2000 on the graph, but we actually plot the first point as the middle point for 2000, and then we draw it to the frequency, which is 1, right, for 01. This picture wasn't really taken the best. It should actually have on the left hand side here, it should have, right where you see here, it should have 1, it should have 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Okay, so we'll actually start from the midpoint of 2000 because that's how we do frequency polygons. And at the end here, we also start at the midpoint of 2011, even though 11 is not there. That's where we start, at the midpoint of the histogram, right? So for this point, which is actually here, 1 to 2001, we actually go 1 to 2001, which is this point right here. Then the next one is 2, which is 2 squares up to 2002, and that's that point there. Then 4 to 2003, 5 to 2005, 6, no, it's not 5 to 2005, it's 5 to 2004, then 7 to 2005, then 10 to 2006, 8 to 2007, 6 to 2008, 4 to 2009, and 2 to 2010. All right. All right, so this draws the frequency polygon, and of course we would just draw the lines here. And we draw them straight, by the way. We don't want them to be lean, we want them to be as straight as possible, as shown in the graph. And that should give us our frequency polygon, right? So now, after we finish doing all of this frequency polygon stuff, we pretty much have the areas in order to find the graph, right? And that's pretty much what we want. It says calculate the area enclosed by the frequency polygon and the horizontal axis. So now this is the difficult part, guys. Well, it would be a little difficult if you've never seen it before. So for A1, which is the first area down here, that's actually half base times height because it's a triangle, and you're gonna end up with half times 1 times 1. The base is here, right, which is actually 1, and the height is also 1. So we're gonna end up with a half. Then for A2, we're going to use the area for the trapezium, which is a half A plus B times H. Alright guys, so we're going to use the area of a trapezium to find the area for A2. So it's going to be half multiplied by 1 plus 2. In this case, here is 2 and here is 1, right? And then this would be the height right here. Cool? So the height is going to be times 1 as well. So we're going to end up with 3 over 2. All right. So A3 is going to be equal to the same trapezium, but it's going to be a half. In this case, it's multiplied by 4, right? And then here is also 2. So it's 2 plus 4 multiplied by 1. So in this case, it's going to be 6 over 2, which is actually equal to 3, right? All right, so for the next one, A4, it's equal to a half multiplied by, let's look at A4, it should actually be 5, right? It should be 4 plus 5 times 1, which should actually be 9 over 2, which is equal to 4.5. And then A5 now is equal to 7 plus 5, right? A half times 7 plus 5 times 1, which is equal to 12 over 2, which is equal to 6. And then let's just move this a bit. Then A6 is equal to a half multiplied by 10 plus 7 actually over 2 multiplied by 1, which is actually 17 over 2, which is 8.5. Then we have A7, which is equal to 8 by 10, right? Am I correct? Yes, 8 by 10, which is a half 10 plus 8 times 1, which is equal to 18 over 2, which is 9. And A8 is equal to half times 8 plus 6, right? Multiplied by 1, which is equal to 14 over 2, which is equal to 7. Then I have A9, which is equal to A9 is equal to 6, a half times 6 plus 4, which is equal to, multiplied by 1, sorry, which is equal to 10 over 2, which is just 5. And then A10 is equal to a half times 4 plus 2, right? 4 plus 2 times 1, which is actually 6 over 2, which is equal to 3. And then A11 in this case is actually equal to half base times height. Because it's a triangle, this part A11 is just a triangle. So I'm going to use half base times height, which is half 1 times 2 in this case, and it's going to end up being 1. Alright guys, so if you actually total all of these, 1 plus 3 would give us 4, 4 plus 5 would give us 9, 9 plus 7 would give us 16. 16 plus 9 would give us 25. 25 plus 8 would give us 33.5. 33.5 plus 6 would give us 39.5. 39.5 plus 4.5 would give us 44. 44 plus 3 would give us 47. And then 47 plus 3 over 2 would give us 48.5 plus a half. So the total would be 49, right? And that's 49 hit records, right? And the reason why we know it's right, guys, the reason why we know that this answer is actually right is because when we add the frequency, right, for this whole question, 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 5 is actually 12, 12 plus 7 is 19, plus 10 is 29, 29 plus 8 is actually 37, 37 plus 6 is actually 43, 43 plus 4 is actually 47, and plus 2 is equal to 49. So we know that the 49 hit records is exactly equal to the area here in this frequency polygon, and we worked it out using the area of a triangle, which is a half base times height, and the area of a trapezium. That's what we used to find all the angles in the graph. And that's pretty much how we work out this frequency polygon question, guys. It's really not too bad. It's really a good question. I haven't seen it too much on exams, but you will get similar types of questions on the exam. So this is definitely a question that we had to go through. So let's finish up the question here. It says, if a year is selected at random, calculate the probability that Lil Wayne had no more than 5 hit records. All right, so no more than 5 would actually mean that you've had no more than 5. So you don't want 5, you don't want 7, you don't want 10, you don't want 8, you don't want 6, and you want the other results. So we're going to find the relative frequency for the other results. So it should be 1 plus 2 plus 4 plus 4 plus 2 all over 49. So in this case, it would be 3 plus 4 gives us 7. 7 plus 4 gives us 11 plus 12 plus 2. Let me work this out again. Sorry about that. So 4 plus 4 plus 2 gives us 10. Plus 2 plus 1 is 13 over 49. And we can work that out. All right. And so the answer is 0.2653. Cool. And that's the answer. That's actually the answer. All right, guys. And so the answer for the relative frequency is 0.2653. All right, guys. So that's no more than 5 hit records. The next one says at least 7 hit records. That's pretty high, right? So in the situation where it says at least, the 7, the 10, and the 8 are included. So in this case, the relative frequency for those is 7 plus 8 plus 10 all over 49, which would actually be equal to 25 over 49, which is equal to 0.5102. All right, guys. Okay, so that's the answer for that one for the probability. And cool, so we finished these two questions. Well, we finished this one question. It felt like two questions the way it was long. And we pretty much finished. All right, guys. So they're really not too difficult, guys. All you really have to remember more than anything is the formula for the area of the trapezium, and they actually give you that on your paper in the beginning, at the front of the paper, and the area of a triangle, which is half base times height. You really can't miss it, guys. And I'll see you in the next lecture. Okay? That's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.